picking up then from where we left off last time, using integration to determine the volume of revolved solids, things like what you would make on a lathe, integration can be used to do that, like this. If we consider the area bounded by those three straight lines, i.e. y is equal to 3x, is that one? X is equal to 1, is that line? And the x-axis there. So that triangle, if we revolve that around the x-axis, we end up with a volume that is a cone. Okay? Which, there's a formula for calculating the volume of a cone anyway, but the idea of choosing that is to prove that the method works with something that you already know in the first place. So, if we look at that and we consider taking small slices from that, so that that's made up of a number of discs. Those discs are of radius y and of thickness dx, or change in x, that comes from the integration. Then the volume of that disc would be pi times the radius squared, which is y squared, times the thickness dx, because the volume of that volume of a cylinder is pi r squared times the height. That's where that comes from. If we add up the volumes of all the discs with an infinitely small disc thickness, dx, we obtain the formula, which is the indefinite integral between the limits a and b of y squared. Or in more general terms, of the function of that shape that was revolved. So any function, this is particular to that cone shape, this is particular to any function squared. Okay? And a and b are the limits of the area being rotated. Okay? If you're using dx, then you're showing that the area is being rotated around the x-axis. And I'm not intending to cover rotation around the y-axis. Are reasonably happy with that so far? Yeah? So, applying that to that shape, so we've got the volume here is equal to pi, so we take the pi constant outside the integral, y squared dx. And the limits here are what? Where do we get the limits from? Is that not a there and b there? Yeah, that's the x values limiting the function. Okay. So we just got to find the definite integral of that. So that's going to be pi times I want you to tell me. What's the function y? Yeah, so what we're actually looking for is the definite integral between 0 and 1 of 3x dx, are we not? I've got to square it yet. How can I further write that? Yeah. Now can we integrate that with what you know? No, it's early on a Tuesday morning. Three x cubed. Tell me how you get that, Jordan. Tell everyone else. Yeah. So we start making the definite the result of that integral. You're saying that integrated is 3x cubed between 0 and 1. Yeah? Is that what you're saying? So that's pi times 3 times none cubed oh, hang on, no. Can't put the minus pi times 0, because that's going to be 0 when x is 0, isn't it? Where did he get pi? Yep. Everyone agree with that? And we could evaluate pi, but there's no real need to. That we've not been given any kind of unit for this. Okay. Formula for volume of cone is V is equal to pi r squared h over 3. So that's pi times r was 3, won't it? Times the height was 1 equals 3. That's 3 squared. It's 3 pi units cubed. So just checking that with the formula. Sorry? Volume is cube, isn't it? Right, have a go then at the one on the following page. Curve y equals x squared plus 4 through taking around 1 revolution about the x-axis between the limits x is 1 and x is 4. Determine the volume of solid revolution produced. Right, gents. The general form is that pi times the limits between a and b of y squared. We've got y squared is equal to x squared plus 4. So we replace with the limits we've got, bottom limits 1 and 4. So we've taken the function of the line we're looking at and we've placed y with it in the general form. So the next job, you all agree with me up to there? I've replaced y in the general form with x squared plus 4 and squared it, multiplied out the brackets to get a function that's ready for integration. So what is that function integrated? X to the 5 over 5 and that's between the limits of 4 and 1. Yep. I got that right? I got that right? Yeah? So that, which comes to pi times what does that bit evaluate to? Someone who's done it. 6952 over 15. Sorry? That's that first bit, yeah? 6592. Take away pi times 283 over 15. And the answer was over 5 pi. Units cubed, or 420.6 pi units cubed. Yep. Okay. There's one more in the notes plus some further ones to have a go at. I don't propose to labour that anymore in the class today. Okay. I'm going to move on now to the other part of today's session.